1-4, properties of real numbers. So my objective in this property is to identify and use the properties of real numbers. And my essential understanding, what we should know, is that relationships that are always true for real numbers are called properties, which there are rules to use to rewrite and compare expressions. Okay, so let's start with this little warm-up in the solve it problem, and let's tell whether each pair of expressions is equal by comparing each statement with equals or not equals. So if I look at this first expression right here, we have 34 plus 12, and then we have 12 plus 34. Well, we'll talk about the name of this property in a little bit, but hopefully you'll see that 34 plus 12 is 46, and that if we do that again, 12 plus 34 is also going to be 46. Okay, so that works out pretty well. If we look at the next one, 100 minus 1 is 99, but 1 minus 100 is negative 99. Well, so first of all, the first one's equal. This one is going to be not equal. 180 plus 0, or sorry, 0 plus 180 is still 180, so that's going to be equal. This first one at the top is tricky because that is not a multiplication sign, that is a division sign. So if I wanted to divide something by a fraction, I would multiply it by its reciprocal. So we have 18 over 1 times 18 over 1, which is going to be 18 squared, not 1. 45 minus 1 is 44, not 45. Okay. And then this is an important property right here, this last one. So that's going to be 6 times 1 over 6, which, if I multiply across the top, I get 6. Multiply across the bottom, I get 6 as well, which is 1. 6 over 6 is 1. So that's going to be an equals. Okay. And while we know that all these properties actually work, there are names for them which we kind of have to remember. Sorry. Okay. So, first thing we're going to talk about is that two algebraic expressions are called equivalent expressions if they have the same value for all values of the variable. The following properties show expressions that are equivalent for all real numbers. Okay, so let's look at the first couple properties of real numbers. So we're going to talk about three letters, A, B, and C, and they're all going to be real numbers, which is important because in order for these properties to actually work, all the numbers that we put into these properties must be real. If they're not real, other things happen, but we'll save that for Algebra 2. So first, we have the commutative properties of addition and multiplication. So addition says that A plus B is equal to B plus A. So that means that I can add things in any order that I want. And my example over here on the right is just like our solve it, okay, just like our little warm-up problem, is that 18 plus 54 is the same thing as 54 plus 18, okay? And multiplication works the same way. A times B is equal to B times A, right? 12 times 1/2 is equal to 1/2 times 12. It doesn't matter what order we add things and what order we multiply things together. We'll talk a little bit about subtraction and division a little bit later, but let's talk about the associative properties first. Okay, so the associative properties of addition and multiplication says that changing the grouping of the addends does not change the sum, or changing the grouping of the factors does not change the product. So notice the difference here in that inside the parentheses we have A plus B, while on the right side we have B plus C. Okay, so the stuff inside the parentheses is what's changing. In my example, we have 23 plus 9 plus 4 is the same thing as 23. Notice now on the outside, and 9 plus 4 together. Multiplications works the same way, where we can have A times B times C is equal to A times B times C, or 7 times 9 times 10 is equal to 7 times 9 times 10. Okay. Now, can get a little bit confusing to try to remember these properties. Okay, so one way that I like to remember it is the commutative property, right? This first one up here. Commuting means how you travel from point A to point B, right? And if you think about, well, how you commute from home to school, the distance you go to get to school is the same distance as from school to go home, okay? So your commute will always be the same, right? Because how you're traveling from point A to point B is the same as how you go from point B to point A. Distance is always the same. However, associative, I kind of remember that by thinking about how you associate with people in a group. So maybe you're hanging out with B one day and you feel like hanging out with C the other day. Okay? So just a little trick to try to remember some of these properties. Okay? Couple more properties we want to talk about. Okay? So let A be a real number. The identity properties of addition and multiplication say that the sum of any real number and zero is the original number. The product of any real number and 1 is the original number. So we have two different things there that when you use the operation, nothing happens. For addition, it's 0. For multiplication, it's 1. Okay? And those are my two identities. They have fancy names. Addition, right? We have A plus 0 is equal to A. This is the additive identity, right? A times 1 is equal to A. Okay? That is called the multiplicative identity. Okay? So both of those numbers are very important. 0 for addition, 1 for multiplication. Okay? And we're going to use those a lot for all sorts of different things. Okay? Next one says the 0 property of multiplication. Okay? This is an important one as well because when we multiply 0 by anything, it is always going to be 0, no matter what it is. The multiplication property of -1. Now you got to be careful with this one because the product of -1 and A is always the opposite of A. So just because you see a negative number there does not mean your answer is going to be negative. Let's look at a different example besides the one that they give us, which is pretty obvious that -1 times 9 is -9. What about -1 times -10? Okay. Well, when we do this, my answer is always going to be the opposite of the thing that we're multiplying by. So I'm going to get a positive 10, which hopefully you realize that negative times negative is a positive. Okay? But it's important to realize that this property is not saying that if you multiply a -1 times something, you're always going to get a negative, right? The negative in the front means the opposite. Okay? Let's try some problems. So the first problem looks like 42 times 0 is equal to 0. Now we're going to try to identify which property is illustrated by this statement. Okay? Well, we're multiplying something by 0, so that is going to be the 0 property of, usually you got to say what it is. Okay, so this would be of the 0 property of multiplication. Okay? So the next one, I'm looking inside the parentheses and I see y plus 2.5 there. I see 2.5 plus 28 there. So this is going to be the associative property of, well, what are we doing in here? So this is going to be addition. Okay. Next one, part C. We have 10 times x plus 0. So what's happening here is we're adding 0 to something and we're getting that same thing. So this is going to be the identity property of addition. Okay. Another way to say that is additive identity. A little sloppy there, but get the idea. Okay. Let's look at our got it problems. And the first one says 4x times 1 is equal to 4x. So now we're multiplying by something, and I'm getting the same answer, right? My answer is not changing. So in this case, my answer would be the identity property. Identity property of, well, what are we doing here? We're not adding, we're multiplying. So the identity property of multiplication. Now in part B, the thing that jumps out at you is the parentheses. So I see parentheses right there, so I should maybe want to think that it's going to be the associative property because the associative property has to do with parentheses. But if I look really closely at the stuff in the parentheses, the stuff inside the parentheses hasn't changed. What has changed is the order that I'm adding that stuff in the parentheses. So part B here is not the associative property because the order that I'm adding things is different. This is the commutative property of addition. Okay. Good. Next. So we can use properties to help solve some problems using mental math. Okay. And if I look at this problem right here, I might be tempted to take out a calculator and try to figure this out using some sort of device to help me. But if I notice something, well, first of all, what's the problem? A movie ticket costs $7.75, a drink costs $2.40, popcorn costs $1.25. What is the total cost for ticket, drink, popcorn? So I got to pay for all this stuff. So basically, I got to add them together. So I could try to go 775 plus 240 plus 125. I could try to do that in order, but that is actually harder. If I use the commutative property, I can rearrange this stuff and add it in a different order. So I could do 775 plus 125 plus 240. And if I want to think about this also with some associative properties here, okay, I could have had these two in parentheses and then switch that to rearrange it and then put the other two in parentheses. But the point is that I see that those two numbers, 775 and $1.25, are easiest to add together. Because when you add those together, you get 9, right? All the decimals go away. Plus 240. Now that is easier to add together to give me my total of $11.40. Okay, so it's much easier if you rearrange something to help you get the problem better. Whoops. Let's get rid of that. Okay, and going down to my got it problem, a can holds 3 tennis balls. A box holds 4 cans. The case holds 6 boxes. How many tennis balls are in 10 cases? Okay. So hopefully you realize that this is going to be 3 times 4 times 6 times 10. So if we wanted to, we could multiply these things together any way we want, and there's no real super easier one that sticks out here, but we can just go 3 times 4 gives me the 12 times 6 times 10. 12 times 6 is 72 times 10. I'm going to save the 10 for last because that was the easiest one. So that's going to give me 720. Um, Not as big of a jump in which one you should combine as the beginning problem, okay? But it's still easier to uh, multiply things first. So let's write some equivalent expressions. And when you look at these expressions, try to think about what properties we're actually using to do this, okay? So when you look at part A, you're probably thinking, well, I could just multiply the 5 and the 3 together. I could just multiply them all together. Yeah, but there's a reason that you can actually do that. So we're never going to sort of go through every single step, but the way this actually works is we can use the associative property and say 5 times 3 times the n. The 5 times the 3 I can do first as a 15, and that multiplies together with the n. Okay, so this is going to be the associative property of multiplication that helps me add those or multiply those two things together easily. Okay, the next one, well, I can start by using the commutative property and switching the stuff in the parentheses around. 7b plus 4 plus the 8. Then I can use the associative property to give me 7b plus 4 plus the 8. And now I can actually add the two like terms together, the 4 and the 8 together, to give me 7b plus 12. Okay? And that is simplified. That is as simple as that expression can get. With part C, we can rewrite rewrite the fraction as 6x over 1 times y over y, right? We're just going to split that out and then simplify that to 6x times y over y is going to be 1. And then we can use the identity property of multiplication to give me 6x. Okay. So let's look at our got it problems down here. And the same thing, we can actually use my associative property first and take 2.1 times 4.5 first, and then times the x. And when we multiply those together, we get 9.45 times the x. Part B is the same as the other one before. So what we're going to do is we're going to use the commutative property first. 3 plus 4h. Then we're going to use the associative property next. Ooh, whoops, not comma. 6 plus 3 plus my 4h. And then that turns into 9 plus 4h. Okay? And then the last one, I can always rearrange the numbers. So we have 8m over 12 times n times n. That is the commutative property. I could then go 8 over 12 n times m over m, which is just how multiplying fractions works. The m and the m cancel each other out to give me 1, and 8 over 12 turns into 2 over 3. So that turns into 2 over 3 n times 1, which is 2 over 3 n, due to the multiplicative identity, right? The identity property of multiplication. Okay? So next, when we looked at that last problem, reasoning and properties were used to show that two expressions are equivalent. This is something called deductive reasoning. And deductive reasoning is the process of reasoning logically from the given facts to a conclusion, right? So you're deducting a conclusion, right? You're using the facts, you're getting an answer, you're getting a conclusion. If we want to show that a statement is not true, right, we want to find an example for which the statement is not true. An example showing that a statement is false is called a counterexample. You need only one counterexample to prove that a statement is false. So you prove it's false one time, that's it. Okay? However, to prove something is true all the time, we need to use some of the properties that we know are always true. So let's take a look at this. Is this statement, using deductive reasoning and counterexamples, okay, it's problem 4. Is the statement true or false? If it is false, give a counterexample. For all real numbers a and b, a times b is equal to b plus a. Well, that kind of looks a little bit like the commutative property, but not really, because we have a multiplication there and an addition there. Okay? So all we need to do now is find one way that this is not true. Well, what if we say that a is 5 and b is 3? So that's 5 times 3, and we're going to say that's equal to 5 plus 3. Ooh, whoops, sorry. Got to make sure this is exact. 3 plus 5. Okay, because we want b first this time. Doesn't really matter because this is 15, and that is not equal to 8. Okay? Let's look at the next one. For all real numbers a, b, and c, a plus b plus c is equal to b plus a plus c. Okay, so if we can rearrange this using some of the properties that we've used already, then we can prove that this is true. So let's use the commutative property first to say that b plus a plus c, okay? And that's just changing the order of these two. Then let's use the associative property to say that I can associate the parentheses with different things to say b plus a plus c is the same thing as b plus a plus c. So using my properties, I was able to show that the two sides are equal to each other. So this is true. Next. So for these two, are these true or false? And if they are false, give a counterexample. Okay. So for all real numbers, j and k, j times k is equal to k plus 0 times j. Well, I can use the, oops, I can use the commutative property right there to turn that into k times j. And then I can use uh, the additive identity, right? That's 0. If I add 0 to something, it is still k, because we can say that k plus 0 is still k. So I can replace this k, I can substitute it with k plus 0 and still multiply it by j and still have the same answer. Okay, so this one is true. So for all real numbers for the next one, so for all real numbers m and n, m times n plus 1 equals m times n plus 1. So if we can find something in here that these things don't work, then it's never gonna, then it's not true, right? If we can find a counterexample, then it is not true. So let's see. So let's try m is equal to 4 and n is equal to 2. And let's see what happens. So that's going to be 4 times 2 plus 1 is equal to 4 times 2 plus 1. Well, parentheses comes first with order of operations, right? So that's going to be 4 times 3, which is 12, is equal to, now multiplication comes first, that's 8 plus 1, which is 9. So that is not true. And all we needed to do was find one time where it didn't work. So if we go back to the very first problem, part A, is it false for every pair of real numbers? So let's go back to the beginning. all the way up top. Is this is this expression always false? Was no matter what we picked never going to work? Well, let's try it again, except this time, let's say A is 2 and B is 2. So if I were to do that, we would have 2 times 2 is equal to 2 plus 2, which is true. So even though I was able to show that the first expression was actually true, right? It's only true for a specific case, right? The counterexample, right? We only need one counterexample to show that a statement is completely false, even though we got lucky this time and it just happened to work for this expression. Okay? So our lesson check. Do you know how to name the properties? Okay? That is commutative. This one is associative. And to do, do simple mental math, simplify that expression. Okay? My vocabulary, tell whether the expressions in each pair are equivalent. Are these two expressions equivalent? No, they are not. And are these two expressions equivalent? Yes, they are if we combine the ones together. And then this expression, right, justify each step. We won't do this a lot, but it's kind of some things that you'll see in geometry where you have to justify each step in the different parts of a proof. So quickly looking at this, right, what's happening here is inside, we're moving it, so that's the commutative. Now we are changing the place where the parentheses are, so that's the associative. And then this is just multiplication and multiplication again. Okay, so that was lesson 1-4, properties of real numbers.